bear with me here. There we go. I'm your host, Patrick Beatty, a marketing manager here at YSI, and I'll be guiding the conversation today, making sure we hit on all the major ways you can save money and time and energy working with monitoring instrumentation. For today's webinar, we've brought in the A-Team to throw down their combined 20 plus years of experience in water quality monitoring for your benefit. After all, here at YSI, we believe fighting sensor fouling is a team sport. First, I'd like to introduce Brandon Smith, who is a product manager for our Sond line.
Hey everybody, welcome to the webinar, and we're certainly glad to have you all with us today. Again, I'm Brandon Smith. I am a product manager here at YSI, and what that means is I help to drive the development of new sensor technology with all our engineers. And a big part of that is customer outreach and really understanding what folks like you guys want in a new piece of equipment. So I've been with YSI for about 3.5 years now, and generating content like this presentation, this webinar, is kind of one of my favorite parts of working here. So hopefully you'll learn something from today's presentation.
And next up, we have Tom, our resident technical support team leader.
Hi guys, I'm Tom Mogenberg, and I've provided tech support to our customers on water quality sondes for just over 10 years. If you've ever needed help with a sonde and called into our support line, you've probably talked to me at some point, or you may have met me at one of the dozens of sonde training sessions I've conducted throughout the years across the US and Canada. Throughout my time with YSI, I've answered over 15,000 calls, not today, but over time, answering questions and troubleshooting anything and everything you can imagine, from questions like, can I attach a sonde to a fish? Which my answer to that was, how big is the fish? To how can I get an extra week or two out of my sonde deployment, which we're going to focus our efforts on answering today.
And last but not least, we have Tiffany Shermer, one of our best and brightest applications engineers.
Thanks, Patrick. Hi, everyone. I'm Tiffany Shermer, and I'm in charge of our R&D test locations around the U.S. My primary role here at YSI is to thoroughly field test products for months or often years to ensure we're producing high-quality data for our customers. I've maintained EXO and 6 series instrumentation year-round in both high sediment and high fouling environments for the better part of 5 years.
Thanks, Tiff, and again, a big thanks to everyone for joining us today. So before we get started, just a little bit of housekeeping, a couple things you should be aware of about the webinar. First, on the right side of your screen, you should notice you have a Go to Webinar panel. This is where you can communicate with us via the questions box. So if at any point during our discussion you'd like to ask us a question, that's the spot to type it in. At the end of the presentation, we'll have a 15-minute Q&A session where the speakers will do their best to answer as many of your questions as possible. If we don't get to your question, please don't be worried. We will follow up with each of you via email afterwards to make sure you get the information you requested. Second, during the presentation today, be ready for live audience polls to pop up during the event. This will help you guys stay involved, and it will help us to tailor this webinar and future webinars closer to your needs. Now that we've gotten a little bit of this housekeeping out of the way, let's jump right into the thick of things with Brandon, who's going to frame today's presentation.
All right, thanks Patrick. You know, the goal of every monitoring program is to gain a better understanding of an environment. And that deeper understanding can lead to better water management tactics and better decision making. So ultimately, to better understand water, we just need more data, and the more the better here. So to tell the full story of what's happening in a river, a lake, a stream, or an estuary, high-resolution data is truly critical. Now, some organizations only have the resources to monitor on a weekly basis with more handheld style equipment. And while that's a great first step to collecting water quality data, a more robust monitoring schedule of even daily sampling can shed light on events happening here. Now, ultimately, no one can be at your monitoring site 24 hours a day, 7 days a week, and even 365 days a year to maintain a high-resolution data set with a handheld. And that's why data sondes are absolutely critical to building a global water quality data set, just like you see here on the screen, and that's what we need. For those of you who are new to water quality monitoring, a sonde is a piece of instrumentation that can autonomously record water quality data in situ for weeks or even months at a time. And these pieces of equipment can be installed throughout a whole entire watershed to capture basic parameters on the health of a water body. And rain or snow, day or night, they're going to continuously collect data until they're either pulled from the water or they just run out of battery power. Now, when sondes were initially developed by manufacturers almost 30 years ago, the primary limitation on how long they could continue to collect quality data was battery life. Sensors were power hungry, super power hungry, and internal hardware components just weren't power efficient like they are today. So a long deployment period for folks back then was a couple of days or maybe even a week if they were lucky. So it wasn't long before power limitations of this type of equipment were resolved by manufacturers like YSI, and that we could collect data for much longer periods of time. You know, the only problem here was we were collecting all this data, heaps and mounds of data was being collected, but what was the quality of that data? Because in many environments, within a week or so, and in some cases even a day at some of these more intense applications, the deployed sensors just get coated in sediment and biofilms and even barnacles, so it can get skewed and nearly worthless pretty quickly. So maintaining equipment became pretty important for monitoring organizations, so you might have to go out into the field much more often than you'd like, and maintaining equipment at that pace made continuous data seem unrealistic from just a logistics standpoint, because sending technicians to service instruments every few days to keep the data quality up was both time consuming but also really expensive. And everything just started to add up financially. The cost of a technician's time, the expenses just to travel out to that field site, and the supplies you'd have to use each time to maintain the equipment, and even the opportunity cost of what could I be doing right now instead of cleaning a sonde. The cost to collect that high-resolution data point and the cost per data point became pretty extreme when the sonde just couldn't quite keep its sensors clean of debris. And it was at this point when sensor manufacturers and sensors and sonde developers really understood that it wasn't battery life that was the problem in collecting high quality and high resolution data sets. It was the volley of algae and silt and microorganisms that harsh aquatic environments can throw at you and really throw at your instrument. And the problem was sensor fouling, and specifically biofouling. So today's presentation is going to focus exclusively on providing you some tips on how to fight fouling and how to collect the highest quality data over the course of a long-term sonde deployment period. And that's going to use a combination of our suggestions. And with those suggestions, you'll be able to significantly reduce the frequency at which your team has to go out to those field sites and clean and maintain instrumentation, both sondes and sensors. So let's go ahead and kick it in high gear, and I'll pass it over to Tom with our first tip.
Thanks, Brandon. So the first tip I want to talk about is using anti-fouling paint to help prevent biological growth on your sondes. If you've been using sondes for a while, you may be familiar with copper-based anti-fouling paint. This is what was commonly used when we first started thinking about extending deployment times. The paint was borrowed from the marine industry, where it's used to cover hulls of ships and effectively prevented barnacles and other marine organisms from growing and reducing the ship's performance. Similarly, a sonde can be painted with this anti-fouling paint to achieve the same effect. Without getting too technical, most anti-fouling paints consist of a copper component like copper oxide and a variety of aromatic hydrocarbons like benzene or toluene, for example. For this reason, you would want to make sure you take every necessary safety precaution recommended by the paint manufacturer when you apply anti-fouling paint. This would usually consist of wearing gloves, using eye protection, a respirator, etc. And of course, making sure you're in a well-ventilated area. A number of manufacturers produce anti-fouling paints that are suitable for YSI sensors. Two products that we have had a good success with are Petit Paint's Trinidad SR and Interlux Act Bottom Coat. Black paint is usually recommended, and both are readily available at marine supply stores or online. A gallon of this paint will cost about $100. There are no long-term effects to using these paints on the instrumentation, but be sure not to get any of this paint on the sonde or sensor connectors. This is where the probes would plug in or the cables would connect. Also note this paint will likely flake off over time, where the old paint will need to be removed and a new coat would be applied. So a sonde painted with copper-based paint will provide quality data for longer periods in the field and require fewer visits for cleaning and maintenance. Organisms have trouble getting a good foothold on the painted surfaces and are also more easily cleaned off. Each sensor can be removed and painted separately, along with each part of the sonde, including the guard. Paint is applied in thin coats and allowed to dry, and then reapplied for maximum effect. This process needs to be repeated periodically. As I mentioned, the paint will flake off, or if it's removed during the cleaning process. And although an effective way to prevent fouling, the painting process is time-consuming, and there are increasing concerns over long-term toxic effects. So the use of copper-based paints may take a little extra time and effort, but it will help prevent organisms from growing on your instrumentation and definitely help you extend your deployment times. So the next tip I want to talk about is using copper components on your instrumentation, which will also help prevent biofouling. So a more efficient and less time-consuming way to prevent fouling, YSI began introducing copper components to be used with our sondes around 2006. Organisms still have a hard time getting attached to these copper components, much like the copper-based anti-fouling paint. The intention of these components is to obviously extend deployment times, but to also provide a faster but just as effective way to prepare the sonde for long-term deployments. Accessories like copper guards, wiper blocks, copper tape, mesh screens, and even copper probes were introduced. And these components immediately began helping extend deployment times with very little time investment. The cost of these components varies from about $70 for a roll of tape to a few $100s for a copper guard. Using the copper components helps increase deployment times much like the copper-based paints do. You can expect about a month or so of life out of a copper tape application before it needs to be reapplied. One tip I do want to pass along about the tape is to not let it deteriorate too long before you remove and reapply it. The tape is much easier to remove if it's still somewhat intact, as opposed to waiting till when the tape becomes mostly used up. So people like me with a less steady hand especially welcome the copper tape, which can be easily and quickly applied to all of the probes within just a few minutes. You simply clean your probes and wrap the tape around them, so they are completely covered as shown in the picture. Make sure you cut around the hole like for the conductivity sensors, so you're letting the water flow through there. The tape lasts about a month or so before it needs to be removed and reapplied, but the actual copper guards, wipers, and probes can last years. In addition, there is less of a concern about toxic effects using copper materials versus the paints, which makes it more environmentally friendly. So remember to consider using copper tape or other components for an easy way to help prevent fouling and extend your deployment duration. Patrick?
Thanks, Tom. That concludes the first two tips of today's webinar, and we'd like to take a quick break here to poll the audience and see where you stand on the following question. What we want to ask is, what determines the frequency of your field site visits? And here you can see a few options in front of you. Bear with me a moment here while I pull up the first poll for you to enter. All right, you should see a poll in front of you now, and again, your choices are fouling concerns, your SOP specs, calibration, or other requirements. Feel free to click all that apply. And I see the polls coming in now. Thank you. We'll give you just a few more seconds for the polls to stabilize. Wow, very active. I'm just going to wait for a little bit longer for the polls to stop coming in. All right, looks like the majority of you have now voted, so I'm going to move along here. I'm going to close the poll, and let's take a peek. Tiffany will just walk us through it, and then she'll share the next point.
Okay, it looks like 61% of you have fouling concerns that determines your frequency. followed by calibration requirements, and then SOPs and other are about the same. Okay, moving forward, our tip number 3 is protecting the sensing surfaces with mechanical wipers and using simple accessories to save on cleanup time. So I realize everyone's number 1 goal is to collect accurate and complete data sets. And the ability to minimize field site visits may be secondary, but it's still pretty important. So there's a host of accessories to assist with deployment longevity. So here's a little side note. Last summer, I deployed a prototype analyzer in the Chesapeake Bay, which is an estuary along the Atlantic that acts as a drainage basin for about 150 rivers and streams. It's a very, very active site. So the deployment was only for a week, and we decided that we would not take any anti-fouling measures with the instruments. Let me tell you, this was an absolutely terrible mistake. The only areas that were not covered were the faces of the sensors that were wiped. The biofouling had accumulated in that short amount of time. It was amazing. This type of biofouling was soft to the touch, kind of like wet velvet, but it did not want to come off with brushing or soapy water or putty knives. I ended up having to soak them in soapy water for several days to remove the crud, and it still took many hours to clean everything. So I would suggest that the number 1 accessory to mitigate fouling would be a mechanical wiper or wiping system. And for those of you that may not know, a wiper is a mechanism that sweeps over the sensor's surface and in our older SON platforms, each optical sensor had its own wiper that had a soft pad to sweep across this area. However, in our newer SON technology, we use a centralized wiper with more torque and stronger bristles to clean a whole suite of sensors simultaneously. This wiping design is more robust because it offers a more thorough cleaning and there's only a single brush to maintain. So using a mechanical wiper will help the sensing areas keep clean of debris, but what about the rest of the instrument? There are other accessories to help with fouling and post-deployment cleanup. Most require basic tools like scissors, an X-Acto blade, and a Sharpie pen to apply. These would be items like shrinkable plastic sleeves, and these form a protective layer between your instrument and the environment and make cleanup much easier. And these typically work well in soft and fouling environments where things like small aquatic worms, mud, and some algae would otherwise coat your SON from top to bottom. For hard biofouling, these sleeves need a layer of copper tape or duct tape over them because the barnacles can penetrate the plastic. So copper components help in 2 ways, mentioning the copper tape. So they act as a deterrent to organics because of their properties, and then they also help reduce post-deployment cleanup. So things like copper alloy screens and guards work well to keep these areas protected. Typically, if you're using these, you may still need some brushing post-deployment, but you won't need a long acid soak. So when items like the copper tape and the guards and the wiper have been applied, the cleanup, like I said before, is so much faster. And these these areas that have been taped can be sliced and then peeled away. So that eliminates time for an acid soak, and it eliminates so many hours of scrubbing and cleaning. So other areas that can't be protected by these accessories, they may need a soak, followed by a scrub with a soft plastic bristle brush, and definitely a clean water rinse afterwards. These would include areas like the topside connectors, the bail, and the securing items. Had a few of these accessories on that deployment at the Chesapeake Bay would have saved me so many hours of cleaning. So to recap, this anti-fouling accessories, the wiper is your best option for maintaining clean sensor faces. Plastic sleeves and copper tape or duct tape make cleanup faster, and copper naturally is a deterrent for organisms from settling. And Brandon will present our next tip.
All right, thanks, Tiffany. So tip number 4 is always to keep up to date with new sensor technology. Even though a lot of the anti-fouling tips we've described so far are great, there's one Achilles heel to most anti-fouling solutions, and most of us know this as the SANS conductivity probe or conductivity sensor. Most conductivity cells are going to be susceptible to interference from fouling and just about one way or another. And many of these sensors have their electrodes buried deep within the probe, and that's far out of reach of any kind of anti-fouling wiper like Tiffany talked about or copper accessory that Tom mentioned. When obstacles like small aquatic life or clumps of sediment or even algae build up within these closed-off conductivity cells, that really interferes with the measurement. So conductivity sensors are designed with drive electrodes that send current through the water towards a receiving electrode, and the amount of signal loss between those two allows us to calculate more or less the conductance of the water. And when this pathway is obstructed by some sort of fouling, then there's an artificial drop in conductivity readings, which directly impacts the quality of the data you're going to see over the course of the monitoring period. Now, because a conductivity sensor is typically the only sensor that's left unprotected from biofouling, so as Tiffany had mentioned, there's wipers, but the wipers really only reach the other sensors, not conductivity in general. It ends up driving the maintenance interval for that reason alone. So left unchecked, if you have fouling on a conductivity probe, that's not only going to impact the conductivity parameter you see in your data, but it also will affect dissolved oxygen and depth or level parameters as well, because those use conductivity readings to compensate for changes in salinity. Now, until recently, there really wasn't a conductivity sensor on the market that was developed to allow a wiper to clean the electrodes that I talked about and to maintain that clear path for the measurement to be taken. But actually, YSI just released a new wiped conductivity probe for our ExoSonde line just recently. And this new sensor is purpose-built for these high fouling, long-term monitoring projects that we're talking about, and it works with any existing EXO-2 sonde. And the innovation here is really that the conductivity electrodes I talked about are no longer buried deep within the sensor. They're actually raised up to the same plane as all the other sensor surfaces. And that allows the central wiper that Tiffany discussed to really thoroughly clean the measurement surface. Now, as with all our sensor technology, we put everything through their paces with pretty intense field testing. It's all around the world, and actually that's one of Tiffany's jobs here at YSI. And she helped us develop the case study that you see here on the screen. Now, in this case, we tested the new wiped conductivity probe against our standard probe, and we wanted to get data that really demonstrated the effectiveness against intense sensor fouling that we've talked about here. And the new probe is in green on the chart here. The standard probe is in red, and that does not have the wiping capability. So the standard probe actually began to see signs of artificial data drift in the first week or two, just due to fouling accumulating on those electrodes. And the wiped probe, as you can see here, continues to collect pretty good quality data over the course of the month-long deployment. So even within a few weeks into a deployment, a few days in some cases, your conductivity data could be off 10 or 15% if you're using an unprotected sensor. So, to reiterate, tip number 4 is always to keep up with new technology, because manufacturers are always coming up with something new that can help you keep sensor fouling at bay. And that may be, in this case, a wiped conductivity sensor, but certainly there's other advances that are happening all the time that could be helpful for you. So keep an eye out for that sort of stuff.
All right, thanks, Brandon. All right, we're going to pause again for the second poll of the day. We want to know is, what anti-fouling measures do you currently use? So bear with me again as I pull up our second poll. All right, you should see that in front of you now. Your choices are anti-fouling paints, copper components, mechanical wipers, or do you have a wipe CT sensor already? Click all that apply, and we'll give you just a minute or so here to let the votes stabilize, and then we'll share them with you. And Tiffany will read them off for us. right, we're getting close to, once I hit about 75% voted, we'll go ahead and share the results. We really do appreciate your input. All right, thanks for voting, everyone. I'm going to go ahead and share the results on your screen. Tiff, why don't you tell us what everyone thought?
Okay, it looks like mechanical wipers are top at 72%, followed by copper components and accessories. And then anti-fouling paint is less used, and not too many people have the white conductivity sensors yet. Okay, so our next tip is taking care of your instrument, and it will take care of you. So I realize accurate and complete data sets are drivers for investing in these environmental monitoring platforms. So I like to use the analogy of maintenance for your car as a comparison for your monitoring platform. There's regular cleanup and tuning, and then there are things that you need a certified expert to perform. Instrument manufacturers provide guidelines for maintenance because they have an awareness of the items that may need special attentions. So think of this like your car's tune-up. The mechanic's going to change out your belts, lube fittings, and make recommendations based on the diagnostic analysis. So when you send your water quality instrument back for a preventative checkup, an expert technician will inspect items like internal O-rings, internal torque adjustments. They'll perform power consumption tests, pressure tests, and specification testing of the system. And I believe there may be a maintenance special going on right now, so check the website for details. So back to, I'm sure most people would not buy a car and then never wash it again after they leave the dealership. So the same is true for your monitoring platform. For example, after a heavy snow or a good 4x4 session in the mud, chances are you're probably going to wash off your grocery getter before summer or your next road experience. This is when you notice things like scratches, dings, rust, a nail in your tire. The same is true for your instruments. Cleaning in between deployments is imperative to minimize fouling, and it also helps you to create a habit of inspecting your investment. Regular cleaning helps to minimize biofouling too, because it removes the biofilms that the microorganisms create. When microorganisms adhere to your instrument surface, they become problematic in a few ways. So they condition the instrument surface, and they provide which provides an enzymatic interaction exchange for nutrients. Then they provide protection against environmental stressors, and then this also increases resistance to biocides. So once they're formed, they change the surface chemistry of the instrument, which can lead to macroorganism growth like barnacles. They also interrupt ion flow, acting kind of like a diffusion barrier, which can lead to localized corrosion. So what are the typical tools needed to keep your instrument clean? Well, you can buy most of them at your local store. This would be things like mild dish soap, dish brush, plastic putty knife, clean water, and tap water is perfectly fine. Non-abrasive scouring pad, the manufacturer-issued CT brush, grease, and syringe. And if you're in a high carbonate environment, something like white vinegar or a 1 molar solution of hydrochloric acid works well to break those down. So for most of my deployments, soap and elbow grease can typically remove most soft fouling. And soft fouling would include things like milts and worms. I like to use a brush to get the bulk of the cleaning off, and then I clean each sensor more thoroughly with a scouring pad. For sites with harder fouling, like barnacles, a short soak and a 1 molar hydrochloric acid solution, typically about 10 to 15 minutes, helps to break down the organisms to a point where the brush and the scouring pad will work, or a putty knife. But be sure to wear cut-resistant gloves. These guys can be so sharp, and you will feel every little razor cut once you make contact with the salt water again. If hydrochloric acid is not available, white vinegar will also break down the carbonates, but it's just going to take a little bit longer, like hours, or you could leave it soak overnight. But after you've done your soak, you should always rinse really, really well with clean water. So then after all of your cleaning has been performed, you should carefully look over your instrumentation. You should check the cable's integrity and connectors and ensure that the connectors are free of debris. I like to apply the grease with my bare fingers to areas like O-rings and connectors, because this kind of lets me catch nicks or grits that could compromise the seals. And then inspecting the integrity of your securing items like the bail, the carabiners, and the chain is really important, because the last thing is that you'd want to do is lose your investment. So now all other water quality sensors plug into the sonde, while your depth port or level sensor is built into the sonde body itself. That makes maintaining your depth sensor easy to forget. The depth port is the hole in your sonde where the water flows through the instrument and then into the internal depth sensor. This port can get fouled just like the rest of your sonde. And you may notice this in your data if you see the depth increasing, like kind of creeping, or you may notice it in like an unexpected measurement when you bring the sonde back to the lab. These are both signs of blockage. So to get rid of the blockage, you're going to fill the small syringe supplied by the manufacturer with clean water. You're going to force that into the depth port hole and then watch the other hole for the water to exit. If it doesn't, then you probably have a blockage. If it's soft fouling is suspected, you should try soaking it in some warm soapy water and then repeat the clean water cleanings. If hard fouling is suspected, try soaking it in some white vinegar. But whatever you do, do not try to clean this area with a brush or a pipe cleaner. You can do damage. If you do the vinegar soak, you should follow up with several clean water flushes. And then lastly, another crucial item to look over is your wiper. This is your first line of defense against fouling. And I can't stress enough how important it is to check your brush for splay or check your pads for wear and tear. Too much splay or wear can drastically reduce your wiper's effectiveness. If you have a wiped conductivity sensor, then too much wiper splay can also cause ineffective grooming of the conductivity cells. Wiper brush or pad replacement is typically governed by your site, season, and sensor payload. So low fouling sites, you might get months of life, while other sites, they may need changing after only a few weeks of deployment. So to recap, this tip covers wipers, instrument maintenance, and brushes. Cleaning instruments well in between deployments and following the manufacturer's guidelines for maintenance will help to protect your investment and give you confidence in your data. Next, Tom is going to talk to you about FieldSight.
Thanks, Tiff. And before I get started, I just want to say thanks to everybody for sending in your questions. Keep sending them in. We're going to field some of those here at the end. So tip number 6 is don't neglect the FieldSight infrastructure. So the way you prepare your sonde before deployment is an important step in ensuring you can prolong the collection of quality data for as long as possible, but it is just as important to consider the deployment site. A well-prepared and fouling protected sonde may last a month or more in a harsh environment, but if you place it in a deployment location that has not had any protection applied to it, you may be wasting your time. The tube or you place your sonde into should also be protected and maintained in much the same manner your sonde is. You may need to apply anti-fouling paint to your deployment tube, which is used to protect the sonde during deployment. You can also use a copper-based tube, so if you aren't using PV, just use a copper metal tube. That helps as well. In addition, you'll likely need to clean the inside of the pipe. So this is often achieved with a brush with a long handle or by removing the pipe altogether so it can be serviced. So this reminds me of a call I took a few years ago. I had a customer who called in who was having problems with his dissolved oxygen probe. Calibrated fine. It also passed his post-deployment calibration checks, no problem. The problem was when it was deployed and taking measurements. The dissolved oxygen readings would drop near 0 in his pipe. So after going through some basic troubleshooting with with him. We talked about the deployment side, and I asked him about the maintenance on the pipe that the sonde was deployed in. You can probably see where I'm going. The person informed me that they never serviced the pipe. So I asked him to go to the site, look at the readings while the sonde was still in the pipe. Then take the sonde out and put it back in the water next to the pipe and see if the readings were any different. He called me back a few days later, and sure enough, once he placed the sonde next to the pipe instead of in it, the readings went up to the DO levels that he was expecting. So they removed the pipe and found that all of the holes that they'd cut into it to allow the water to flow through were covered with organisms. And then when the sonde was inserted, it was creating some water exchange to the bottom of the pipe, which caused the DO to go up initially. But as the sonde sat there, the water became stagnant and the DO began to drop. And he was basically measuring the water quality of the microenvironment inside the pipe. So once the pipe was serviced and the sonde was put into place, the problems with the DO disappeared. So this is a very good example of what can happen when we only focus on prepping our sonde and forget about the actual deployment site. So a few other things I want you to think about in regards to the deployment site are if you're using solar panels to charge a battery which powers the site, make sure the solar panel is pointing in the right direction, of course, and it's kept clean of branches and leaves, as well as the most common type of fouling, which comes from birds. I'll let you figure out which part of the bird that comes from. So another thing is make sure the site you pick is easily accessible. If you can choose a site which doesn't require a boat, a 2-mile hike, or other special accommodations to visit, then choose that route. Although I do know of at least one customer we have who uses a helicopter to reach their site. There's no getting around that sometimes. So if it's easier to access, then it automatically makes it easier to service, and that in turn helps to extend the deployment time. Here's a link that wanted to share with you. It's to a website which has some great information and documentation you can download for you to use as a reference to help you choose and set up your deployment site. I encourage you to check it out.
All right, thanks, Tom. Since we don't have a lot of time to let everybody jot this down, we'll make sure that in the follow-up email to the webinar, we send out a couple of these links to you, just as a reminder. So tip number 7 and our last tip today is to use telemetry to keep an eye on your field site. A lot of monitoring organizations, really don't take advantage of using telemetry systems at field sites. And you know, there's a lot of reasons why this might be the case. One, of course, is just the cost of it. However, you know, having the ability to view your sonde's data live, it's a huge advantage when we're talking about fighting fouling. Now, for those of you that are unfamiliar with telemetry, water quality sondes can be connected up to data loggers, and they may have the ability to wirelessly communicate data to a web portal, or even an online database. So we call telemeter data getting data from your sonde wirelessly to a database. Now, with access to your field site's data just right at your fingertips, just looking at a smartphone or a computer, you can let the instrument inform you when it needs maintenance. If you regularly are reviewing your data, you should have a good idea historically of when certain parameters may appear to be impacted by some kind of sensor fouling, and generally you'll start to notice large unresolved spikes in your optical sensors, and connectivity data is going to start to drift downward as well. And here's just a couple examples to give you a sample of what I mean. The idea here is to use your live data to drive the frequency of your maintenance visits to a site. Now, the intensity of sensor fouling is highly dependent on seasons and weather patterns. So having a really strict policy of servicing field sites on a weekly basis or a bi-weekly basis, that might not make sense year-round, because in general, the higher the temperature and the higher the salinity of a water body, so typically during summer, the more organic fouling that's going to be an issue for your equipment. Now, on the other hand, for field sites that are having difficulties with sediment fouling, seasons with higher rainfall are going to be your problem time. So you may have to spend more time out in the field during those seasons and less in others. So having a strict schedule could be a waste of your resources. So take advantage of telemetry and that live view of your SONS data to help you decide whether or not you really need to spend your time, your energy, and your organization's resources to be out in the field versus doing other things.
All right, thanks, Brandon. That concludes the last tip for the day. Before we move on to the conclusion and Q&A, let's do one final poll question. We just want to know, how shall we follow up with you if you'd like to be followed up with? So I'll go ahead and pull up the poll here. We will not be reviewing this poll's results. This is for our use so we can better serve you. While you're all queuing in your votes, here are your options. You can ask for a brochure about EXO. You can ask to see our wiped CT case study that Brandon mentioned earlier. If you'd like to speak directly with a specialist or a tech support individual, you can click that option. And you can also be requested to be contacted directly, and that will give us your email, and we can follow up with you in greater detail. And again, if you'd rather not be followed up with, that is an option too. So we'll give you just a minute or so to get maybe about a 75% vote count, and I'll close down the poll, and then Brandon will wrap up today's presentation before we move on to the Q&A session. All right, that's about 75% vote, so I'm going to go ahead and close down the poll. Thank you very much for participating in all these polls today and your patience. All right, I'm going to kick it back to Brandon to wrap up the conclusion.
All right, thanks, Pat. So ultimately, if you're going to use SONS to collect water quality data autonomously, it's almost inevitable that you're going to run into some sort of issue with sensor fouling, and frankly, that's just a part of the job. So try to save yourself a headache by using some of these tips we talked about today, and I just want to run through them again just to make sure they're fresh in everyone's mind. So to summarize kind of the major points here, first of all, if you're in a really, really harsh environment, consider using those anti-fouling paints Tom mentioned to deter some of that really, really heavy biological growth. When available, try to use those copper components, the copper guard, the copper tape, those accessories on your instruments just to give you some passive anti-fouling. When possible, always use some sort of anti-fouling wiper system to keep your sensing surfaces clean, because really that's how you make sure you're getting high quality data over the course of a long-term deployment. As I mentioned earlier, just keep an eye out in the marketplace for new technology, not necessarily just from YSI, but all manufacturers, because new products are coming out all the time, like the wiped connectivity probe I mentioned, that really can help you protect your data and extend those maintenance intervals. As Tiffany mentioned, you know, always take care of your SON, and it's going to take care of you. So when you go out to the field and you do spend that time and effort, make sure you're doing it right by properly cleaning and caring for your instrument. But when you're out there, as Tom mentioned, don't just focus on the SON. Take a look at your field site in general too, because that is equally as important. Maintain that site infrastructure. And last but not least, as I just mentioned, if you can afford it, try to use telemetry systems to get that live view of your data, and that can really drive whether or not you need to visit the field site as often as you are. So some of these suggestions might require certain accessories or probes. What I would say is don't be intimidated by that. Don't be intimidated by the cost of these items, because oftentimes they're going to pay for themselves in no time. And that's in savings from those wasted field trips. And if your sites are really, really remote, some of our customers have to fly into their sites via helicopter. You can imagine how expensive that is. You know, just saving one visit out into the field a year can really pay for this stuff. So if you can extend a SONS maintenance interval on your equipment from once a month, or excuse me, once a week, just once a month, you know, imagine the savings from that, because you're going out into the field a fourth as much as you were before. And frankly, this money could be spent on additional sensors, monitoring different locations, doing just something that's more productive. So think about it.
All right, thanks, Brandon, and a special thanks to Tom and Tiffany for helping us present today. There's a lot of great information shared, and we're really hoping it's going to be a big help to you guys out there. So that's today's presentation, and we've had quite a few questions submitted. So let's change gears for the next 15 minutes or so. I'm going to kick off the Q&A session of today's webinar. As a reminder, keep using that questions box in the corner. We will try to answer as many as we can right now, and if yours goes unanswered, we will follow up with you via email over the next few days. So we hope you stick around. If you can't, no problem. We totally understand. We want to thank you for a great session and participation. And I'll go ahead and pick the first question to get things started. I like this one. One customer asks, our team has a pretty small operating budget. Things like telemetry may be too expensive for our group. What would get us the most bang for our buck?
Well, Patrick, I would have to say for the ExoSonde line, I would say a centralized wiper. Any kind of mechanical sweeping across that measuring surface is going to help collect, extend your deployment and give you good data.
And I agree with you, Tiffany. One thing I would add is if you want to get started and see if some of this anti-fouling measures can help you, roll of copper tape is pretty inexpensive, and it's a good way to just quickly get something that you can wrap around your probes and see if that works for you. So the wipers are great, and they definitely keep the sensors clean. As a very economical start, though, a roll of copper tape might be a good way to go.
Another question that we got here is just asking about productivity. So in high salt, high salinity applications with higher temperatures, is that going to generate more fouling than maybe a freshwater lake? And the answer is always it depends, because some places like Tiffany mentioned in the Chesapeake are quite productive, but it's hard to compare that to something like the Middle East. I've talked to customers that are deploying over there, and they might have to visit their sonde every day, and that's with wipers installed, because it's just so intense. The temperatures are so high. It makes the perfect environment for some of these biofilms and organisms just to latch on. So it depends, but in general, yes, more fouling is present, at least on the biofouling side, in a higher temperature, higher salinity environment. And one of the other questions here I just want to get to real quick that's more procedural. People have asked if a copy of this webinar will be available later. Yes, we're going to have an on-demand copy. It'll get emailed out to everybody. So keep an eye out for that. If you want to share this with other folks in your office, feel free to do so. And we'll get you that link, as well as some of the links to the guides that Tom had talked about.
So there's another question on the list here that is asking about specifics about anti-fouling paint and whether or not it can be used for a specific application. Well, there are very likely regulations or requirements that vary across the U.S. and other countries. The thing to do is to get with your local agency, your environmental protection agency, or whatever agency you might have locally, get with them and see what's allowed. I do think the regulations, for example, are pretty strict in California versus the Midwest. There's different types of anti-fouling paints. Some actually have biocides in them that release over time. So I know some of those are not allowed to be used in specific lakes and other streams. So I can't definitively answer the question. The best thing to do is to just get with your local agency and see what kind of regulations are present for your area.
And I'll add into that just a second here. So this particular question was asking about drinking water monitoring or source water monitoring. So that's water that's about to come into a drinking water facility. So I personally would shy away from anti-fouling paints in those environments, because that's pretty critical, and people are keeping a close eye on those. And obviously we don't want any adverse effects, whether we know them or not, or expect them or not, to happen in that environment.
All right, quick note, we're going to take another question here, but I want to point out on the screen right now, the link to the blog is incorrect. We have a new link. It's now ysi.com/blog, and we'd love for you to join us there. We post things about webinars. We'll have a link to the download there as well, in addition to the email. So be sure to check that out. We'd love to have you read some of our posts. For the next question, what is the most challenging experience you've had with sensor fouling? And Tiffany, I bet you might have a good response to that. Perhaps Tom, which whoever would like to chime in.
Okay, I think maybe the Chesapeake Bay took the cake. I had never seen anything grow like that before. It would not scrape away. It had such a great foothold. So I would say that's probably the worst that I've ever seen. But even that, you know, you can clean it off. It just takes a lot of time. So.
Okay, so one of the worst stories that I can convey, or I guess best stories, however you look at it, if you're looking on the outside or if you're actually doing it like I was. So I was down in Florida and I was helping clean up a sonde that had been deployed for, gosh, I think it was almost a month, and there was very minimal fouling protection applied to the sonde, and that was intentional because it's like a control. We wanted to show, okay, if you don't protect your sonde, this is what it looks like, and versus putting anti-fouling measures on it. So we pulled the sonde out of the water and took it back to the ISS office down there in St. Pete, and it was covered in barnacles and a bunch of other things that I couldn't recognize, so I didn't really know what was on there. But the barnacles were razor sharp, like Tiff mentioned earlier today. And I tell you what, once you get it out of the water and it's in the summer, it stinks. And the flies started swarming in, and I'm standing outside in the heat, knocking barnacles off this thing, and you know, hands are soaking wet, and it's pretty nasty. And then of course in Florida, what happens? It starts raining on me while I'm out there. So I was just waiting to get hit by lightning or hit by a truck just to finish me off. But that was a pretty fun story. I couldn't even get the guard off initially because so much hard growth had grown in between the sensors and the guard. I could not unscrew the guard. So I had to knock off a bunch of barnacles, get the guard off, and then keep plowing. We did actually put that sonde into vinegar overnight to help loosen things up, and then I got to go back for round 2 the next day. So yeah, that's my favorite story.
Yeah, that's a pretty good one. I don't know that I could beat that, but let's try another question here. We have tons of them to go through. By the way, guys, I don't think we're going to be able to get to all of these, so I still encourage you to ask any questions right now. If you get them in the questions box now, we're going to spend the next week or so when we get a chance to respond to everyone. Even if you just have a technical support question, we're happy to help out with that as well. So just type them in there and we'll get back to you. One of them here that I think we covered a little bit, but maybe Tiffany could jump in and talk to is, someone asked if you have really hard fouling that's burrowed deep in those conductivity, the standard conductivity probe, what should you do to get that out? How do you break down that hard fouling and clean that up?
Okay, so is this carbonate fouling?
You know, it doesn't say specifically here, but if you get something deep in there, what do you do? I think that's the question.
Okay, so if I know the site and I suspect that it's carbonates, I'll do an acid soak, either a 1 molar hydrochloric acid solution or some white vinegar, depending on what I have on hand. And then I follow that up with some clean water, and I use the CT brush to scrub up in there. And if it's more of like soft fouling, usually if you run it under some warm water, that'll start to unclog it, and then you can use the brush and again clean again with your clean water.
And I just want to add something. There was another question that's kind of related to this. They asked if using copper screens helps you with the CT probes. And I look at the copper screens as kind of an ounce of prevention. So it may prevent some larger organisms from getting into the ports of the conductivity sensor, but it's not going to keep some of the silts and barnacles and microorganisms from getting through. So it kind of qualifies as the better than nothing routine. So we definitely have used our own copper mesh during our deployments, and again, it's just a little prevention is better than none.
There's a couple of questions in here. I'm trying to answer some of the more popular ones. They're asking specifically, does YSI do any SON trainings in my area? Yes, we're always out and about doing SON training, so if you have a particular request of your region would like to have a specialist come down and work with you, that's something that we can certainly entertain. Just send us an email or even add in the questions box here that you're interested in doing so. But with that said, if you at least work with EXO, we actually have an online training course that's free, completely free for anyone that uses the instrument. So if you have new technicians that are coming in and out of your office, it's about I want to say a 4-hour training, something like that, 4 or 5 hours, something like that, that you could do on your own time. It's a mix of videos and some PDF guides. It's going to walk through some of the stuff we've talked through today, plus, hours and hours of content more. Specifically, it does cover, since we just talked about cleaning, there's a whole section on how best to clean and store your instrument, how to set up your monitoring site. So there's a lot of good information there. I encourage you to check that out. It's exo-university.com, and we'll make sure in the follow-up email we send a link with that in it as well, just in case you guys are curious. Let's see, any other questions here? Tiffany, it looks like here's a question. Does using the copper accessories have any kind of negative impact on aquatic life? So I presume they're talking about fish or marine species at all?
So I don't do a lot of like the whole ecology study while I'm doing a deployment, but in general, we haven't seen any like harm done at a site. Like there's no like dead zones, or there's still a lot of productivity in the area. So I don't think that is a big concern.
Okay, great. Another question that I'll chime in here on is, people mentioned what other types of anti-fouling devices are out there right now, because there is more than just necessarily using copper materials or wipers. There's a wide array of kind of, I won't call them experiments, but new technologies that are just starting to hit the market. One of which is using UV light to really kill some of these microorganisms before they get started. So how that basically works is you have a really, really high-powered UV light, think like a tanning bed light almost, and it is just constantly hitting your sensors on a pretty regular basis. So when these really heavy fouling parts in, let's say, the Middle East or the Gulf of Mexico happen, the first thing that happens, as Tiffany mentioned, is there's just this light film that starts covering the instrument. And then once there's that nice environment for these larger barnacles and organisms to latch onto, that's when fouling gets horrible. So this UV light really hits that biofilm before it even picks up speed, and it kills that right off the bat. So there is no cushy environment, if you will, for those barnacles to latch on to begin with. So there's new stuff out there that's starting to emerge. It's all pretty brand new, and I think manufacturers are kind of learning what not to do almost when it comes to this sort of stuff. So I'd keep an eye out over the next year or two. I think UV technology is certainly going to be a big one that pops up, but we'll see. But there's lots of new stuff.
Okay, so there's another couple questions in here that I want to address. They're pretty similar, and the person's asking if they should, how do they differentiate between drift due to sensor electronics versus fouling drift? So should they take the sonde out of the water and test it before they clean it or after they clean it? And the answer is kind of both. So you should test it in standards that you trust before you clean it, so you can get a baseline. Okay, what is my turbidity reading? What's my conductivity reading, DO, etc.? What is that reading before I clean it, and then go through the process. And don't calibrate it yet, but then you put it back in those new fresh standards again and say, okay, now what's it reading? So if your turbidity or if your conductivity goes up by 40, 80 microsiemens, whatever it is, then you'll know that it was due to the fouling and not the sensor. So just to kind of recap that, it's both. So take it out of the water, do a check before you clean it and one after. Oh, and another thing you might want to do is take pictures of the sonde before you start the cleaning process, because what may happen is you're going to not look at that data for a while, and then you'll go back weeks, months later and start looking at the data, and it may not make any sense. So if you have some pictures, you say, oh, when I took that sonde out, it looked like a science experiment. It didn't really look like a sonde anymore. So that taking pictures once you take it out of the water is definitely a good idea.
Oh, and I have something to add to that, Tom. So what I like to do is I keep a bucket of aerated tap water on hand at all times. And before I deploy, I throw my sonde in there, I take some measurements in that, and then when I bring it back in, tap water is inexpensive, so I can throw my sonde in there and I can look at that, and I know what my baseline should be based on pre-deployment data. So that's like a quick and dirty, as anything, completely irrational to knock it out before you actually go into your standards.
Right. So you don't really know, or we don't have a number. Okay, your conductivity should read this in tap water, but the tap water you have, for all those people listening, you can get a baseline. Okay, my tap water is 400 microsiemens or whatever. The turbidity is 3. The DO should be fully saturated if it's an aerated bath, things like that. The pH should, whatever that is. And it doesn't matter what those numbers are. It's just they should remain pretty constant between before you deploy this on and then after when you bring it back. So it's definitely it's a controlled environment where you can have a good sense of what the numbers should read, relatively speaking.
Right, and one other thing, that tap water should be aerated for at least an hour.
Before you put it in there, right.
Yeah.
I know we're running over, but we have so many great questions, and there are still so many people hanging on despite their busy day, that we're going to let this roll over, and we're going to exhaust a few more of your questions before we end the webinar. And I'll go ahead and pick another one, and anyone can grab it. One of our customers asks, is there any impact on sonde fouling with respect to angle of instrument deployment to flow?
So I guess I'll jump in here really quick. I presume they're asking, is there a certain angle and maybe a river that you should point your sonde in order to avoid some sort of fouling? At least that's how I'll take it. We actually have, Patrick has done a great job of putting together these one-page deployment guides. So for a horizontal deployment, like something that isn't quite deep, like a river or a stream, there is a particular way that you should align your sonde. If you have that question, I'll find you in this list afterwards. I'll send you that guide, but in general, do you guys have any tips that you'd share for like a horizontal deployment in a river? Anything particular, even so far as, yeah.
I can chime in a little because I worked with Mike Lazat on that. There are a number of concerns, and if you'd like I can send you the document, but silt and other forms of objects being carried downstream are one of your biggest concerns, because instead of this vertical deployment that allows for good flow of things away from your instrumentation, in a shallow deployment there's, I guess you could say, less space. So things can get captured in your guard, which will obstruct readings, and so maintaining that flow and trying to get that instrument in some kind of depth of water is very important. And because it's so shallow, even things like tree branches, things like this can become very dangerous for your equipment. We had a case in Alaska where they had to nail chain everything down, and even with a flood, the only thing that allowed them to retrieve their equipment were these chain lines that were tied to trees. So again, if you're doing a horizontal deployment, especially in shallow waters, send us a message, add it to the questions box. I can send you a deployment guide for both vertical and horizontal deployments. It's got, how to drill the holes in your, setting up a deployment cage, things like this. Obviously, we want to protect your equipment, so we can get that to you.
Yeah, I guess I have one more point. And
Please.
Sometimes if you are if your site is from a bank and you don't have a dock that you're deploying the sonde from, you can't necessarily deploy the sonde vertically. So you have to kind of go at an angle because you're from the bank. So by default, the pipe is at like a 45-degree angle or something like that. So if you're going to do that, just make sure that your sonde deployment tube is not in the sediment, or it's not going to be covered in sediment. Make sure you give it enough distance off the bottom of the body of water where it's not going to be resting in sediment. That actually, we take calls in tech support about that quite frequently, where the sondes seem to be fine. They put them into the deployment tube, and then the readings start acting crazy. The tube's not dirty, it's just that the sonde is sitting in the mud, basically.
All right, we got another question here. It's kind of fun and involves tiny animals. How do I keep crayfish and small fish out of the sensor guard?
So there's no really great way to do that unless you put like a copper mesh or something on the outside of your sonde guard. I have, in my deployments, I have lots of crayfish creeping in there, and sometimes they go across the sensors when it's taking a measurement. Most of the time they don't.
And how do you know if you're looking at the data? This is just a question for me, actually. That's why we have the applications engineer in the room. How do you know when you're looking at the data whether or not something's fouling, or maybe it's just a fish has swum by in that particular moment where the measurement was taken?
So typically that'll present itself in like a really irrational number in the data set just for a second, and then it goes back to the normal trends.
Yeah, I just was going to add turbidity, for example. So if you've got something parked in the guard and your turbidity probe is running, it's going to show up as a spike in turbidity because there's a lot of reflectance when that fish or crayfish is parked in there. And I guess you could tape a picture of a shark to your sonde guard too, and that would keep fish away.
It looks like David Walsh has chimed in here, and he says, "Yeah, we use copper mesh around the sonde guard to keep those little guys out." So hey, it works. Try it. You know, there are interesting strategies for keeping some of this stuff away, and a lot of it's not something that a company sells. It's what you can think of that'll work. So we're going to spend, let's say, another 2 or 3 minutes answering questions, and we'll wrap things up. Thanks, guys, for spending so much extra time with us. This is, gosh, we're almost 10 minutes over the presentation now. So one last one. Let's pick a good one, guys. Let's see here. Do copper accessories impact calibration? I think that's one that we can answer pretty well. And one of them specifically is talking about turbidity. Is there any reflection on that guard that could impact your turbidity reading, or is it okay to use that? So feel free, either one of you, to jump in.
Okay, so yes, copper can affect calibration. It does affect, I believe that there are certain sonde bases that you can get that are patinaed to counteract that reflectance issue for turbidity. But on FDOM, if you have the fluorescent dissolved organic matter sensor, that one you do not want to use anything with copper. It'll start to quench the fluorescence of your standard, which would be your quinine sulfate. So you definitely want to stay away if you're calibrating an FDOM sensor.
And specifically with turbidity calibrations, you know, it's different if you're doing this in the field, but if you're doing your calibrations in the lab, it never hurts to have an extra guard that you keep just in your lab, just for calibrations. You'll never have to clean it of fouling before you do your calibrations. You know, keep a separate one for when you take it back in the field. At least when we do it in-house, that just makes things a lot easier.
And this will be our last question, so thanks, guys, for entering those. Again, if you want to have a question answered or your question hasn't been answered so far, make sure it's in the questions box, and we'll have one of our experts follow up with you again over the next week. So our last question here kind of ties back to one of the discussions we'd had just a few seconds ago, and that was, how can, this is from Kevin, how can you tell the difference between drift that's due to a fouling event or fouling covering your versus an actual event that's just lasting for a really long period of time? And again, anybody can jump in on that one.
Yeah, so I think part of that would be just observing the site or even historic data. So if you have historic data for the site, you kind of know a baseline or have a baseline of what typically happens there. And let's say, you know, if it's a parameter that changes, everything else, the temperature isn't changing, dissolved oxygen doesn't appear to be changing, conductivity is fine, but turbidity has that spike, then maybe it's one of our fish or crayfish friends that decided to stop by and say, hey. But then again, if it looks like everything is changing, so we can use the other parameters as an indicator. Temperature goes down, turbidity goes up, conductivity goes down. Maybe we're in a saltwater environment or a brackish environment. So what does that indicate? That'll probably indicate some type of rain event. So you have to look at other parameters sometimes to help clue you in as to what happened. That's definitely one of the biggest challenges when people send us data sets. We weren't there. We have no idea what's going on. We don't have pictures or anything. You know, we'll start asking questions. What did you see? Were you there? And, you know, trying to get as much info as possible. But, you know, we try to look at some of the other parameters, and sometimes they help clue us in because there's telltale signs sometimes as to what's causing these things and whether or not they're quote-unquote real events or if they're created by outside forces.
Yeah, I agree, Tom. The other thing that I like to do is I also like to keep a log of the weather for that site. So like if we had a big rain event, I know that happened on Thursday the 21st, and you know we got like 2 inches of rain that day. So things like following the weather, keeping notes on that will help you whenever you go back to look at your data later.
All right, everybody, we've run over quite a bit, and we know you have busy things to get back to, so we're going to wrap it up for the day. As mentioned, any questions we weren't able to get to today, we're going to follow up with you, don't worry, and over the next week or so. So make sure we'll get everyone the information they need. So we hope you enjoyed today's webinar. Thanks for participating. Don't forget to check us out online, Facebook, Twitter, and of course, again, I've already mentioned that the blog link on your screen right now is inaccurate. Please go to ysi.com/blog for our new blog with all the latest content. So we hope you enjoyed it once again. And from everyone here at YSI, we wish you success in your environmental monitoring efforts. Please have a great day, and thank you.